bell?
Yes.
Yeah, let me turn off the bell. If I can find it. Where did you go? Oh, wait, here it is. Play chime. Okay. All right, I think we're good to go.
Should I start? Continue? Yes. Okay. Welcome, everybody. I'm Giuseppe Matulli. I'm working at the Yale Center for Research Computing, where we emphasize the use of computation in different aspects in environmental science and medicine. And I am the person that dealing with geocomputation. Geocomputation is really the computation of geographic data, the manipulation of geographic data to achieve different kind of environmental uses. These data are becoming bigger and bigger, larger and larger, as you saw in the last 10 years. So you really need powerful tools to be able to compute large processing analysis. You also need a very huge computer, so a supercomputer that we are using at the Yale over here. So the combination of power tools and power computer could allow you to perform a very large analysis. Nonetheless, these tools, especially the GDAL and PK tools, they can be used also on your laptop. So you don't need it to have a supercomputer to allow the computation of your laptop. And especially if you've been experienced issues of RAM limitation and so on the use of R, for example, with the Raster package, using GDAL and PK tools will allow you to overpassing this RAM limitation and achieve big analysis also in your computer. So we are going to perform 4 different web seminars. In particular, today I'm going to talk about raster and vector processing using GDAL. Tomorrow I'm going to talk about image processing using PK tools. This one is a super powerful command line utility that I would say is the brother of GDAL and has the same kind of thinking. So it's very easy to combine both of them. Then we will move on Wednesday. We will move on GRASS GIS, really powerful tools for different kind of GIS operation, also in hydrological modeling, in forest connectivity, path analysis, and so on, through command lines. And we will go further on Thursday when we want to combine all these kind of tools in a supercomputer and be able to operate in a clever way for processing these large analysis.
Giuseppe, 1 second. Can you turn up your mic a bit?
Yes.
And we see a black box in the upper right corner.
Better now?
Now it's worse.
Perfect, thank you.
Yeah.
Sorry?
There's a loud humming noise in the box.
Loud noise. Maybe it's the fan of my computer, so I can change. I can reduce it a bit.
Yeah, reduce it a little bit. I think that's
better.
That's better than it was. Yeah.
Perfect. So so we can continue by pressing the material over here. The Spatial Ecology DocuWiki is a web page that I maintain with all the different code that have been collected through the years, focus on geocomputation, and we don't concentrate only in one language, but we cooperate. We try to get the best of each single language. You can find different exercise in our language, in Python, in GRASS, in GDAL and PK tools that we are going to see today, and different tips in the cluster processing and parallel processing for geographical analysis. we are going to see a very small section of all the material that is present in the spatial ecology .NET. So feel free to navigate afterwards and see all the tips that I've been collecting to the years to able to transfer the geocomputation skills to other people. We also organize courses of 1 week. Actually, this one was supposed to be 1 week long training at Yale University, and then due to the pandemic, we transferred to a web seminar that allow also to people outside to Yale to listen this web seminar without problem. So if we click in the material, you can arrive directly to a web page that I set up in this way. This way we can work and keep seeing everything. You arrive to this web page that allow you to follow the exercise for today and for tomorrow, GDAL and PK tools. I keep it the same material and the same page because GDAL and PK tools, they can really work together. So I will try to strengthen the use of these tools. First today GDAL and tomorrow PK tools. So through my talk, I will present a really easy exercise that you can see as a single element, but whenever you combine all of them, you can really combine all together. You can make a really very complex analysis. I will take a look from time to time to the Zoom question over here on my right. And if I see questions that are related to what I'm talking about, I will try to reply. If not, we can concentrate our attention. We can concentrate the question in the end of the talk. So in the first line of this section, you can see how you were going to connect to the user, to the Linux virtual machine. So I can see that some of you guys are being already corrected. In other words, all the people that ask me about the user ID is this one. So each single person, if you were registered on time, we were giving different user ID for be able to enter. And then we were providing also the key to be able to enter in the virtual machine. Anyway, if you are not able to enter, don't worry. Follow the exercise and try to understand the concept, and then you can replicate in your computer. Also, because over here you can download the data directly that we are going to use it, and you can also download in the scripting procedure. So afterwards you can replicate inside to your machine whatever has been achieved over here. So for now, the most important part, and that you really understand the power of this program of GDAL. Okay, so a bit of step backward in the analysis of the main aspect of GDAL. So GDAL stands for GDAL. If you just Google it in the you arrive to GDAL.org. That is really one of the most important program in the geographical context, geospatial attraction library, and is behind several programming, software, among them private software, but also open source software. So you can see really that there are the typical RPGs, Esri, and so on, Iluit, Idrisi, Map Server, and all of them in the back part they use GDAL. So this is really try to show you how much is, even if you don't see all the software, they use GDAL on their engine. So our main focus of today, how we can use GDAL directly in order to avoid to passing through all this software and having the most powerful raster analysis and vector analysis in our computer. If you click over here on the raster program, on the programs, you can see that GDAL has different utility of command line. So you can have programs that are dealing with raster programs. So with a TIFF, for example, then you can have the one that are dealing with the vector programs. So with the shapefile, and some other that they just come up in the last 1 or 2 years that are working with a multidimensional raster program or geographical program. So for these two, I don't have, they are quite new. I don't have any example. And also I consider most important the vector and the raster analysis. So I will concentrate my talk on this one. Please, every time that you are approaching to use a GDAL command, use this web page. Keep reading every time, because they are developing very fast. So when I started using doing geocomputation 15 years ago in the Linux environment, this one they were just 3 of them. So now they become more than 20, and they are adding more and more. So you can really understanding very well the power of this command. Every time that you click in one command, you can see the syntax of this command. That for people, you can already recognize immediately the syntax that is the typical bash syntax. So where you have the command, all these options between square brackets are optional. So you can insert or not insert it according to what you want to do. They are always starting with a little dash, and they're also called flag. Okay, so in this case, for example, the only part of this command that are compulsory that you have to insert it, you will have the source and destination file. All the other are different flag that you, in according to what you want to do, you can insert.
Giuseppe, there's a large black box in your upper right, and it's obscuring some of the words on your screen.
This one is the question one. Christine?
Sorry, yes, that one. Can
Perfect.
you get rid of that square? Or make it even smaller?
I can remove completely.
Oh, that's better. All the way to the right, maybe.
Just want to keep it for giving an eye to the question.
Or maybe put it on the left instead.
Okay.
There, that's better.
So all these flag, they're really helping you to navigate in the complex of each single option flag and try to understand it. Moreover, if you're scrolling very deep in each single program, you can see that there are examples. So in this case, for example, using GDAL warp, setting up the projection, the typical 4326, the one that the Google Map and all the lat long is using, target resolution. So you go from, let's say, for an unprojected map to a projected map with a specific metadata, and so on for the different, all the different examples. So we are going to see this kind of example in each single study case and see what they perform. This one, the GDAL warp, was for changing projection. So it's one of the most powerful one, and is very, very well used among all the other. So let's see, I will not have the time to go to all of them, but let's see the most important one. GDAL info is really the one that is helping you to understanding the kind of data set, the raster file that you have. So they give you information about metadata, and they give you information about size of the image, pixel size, row and column. And is the first things that you do it every time that you receive or you download raster file is to use GDAL info to understand what we are going to process. So another one very important is GDAL translate, that is allow you to navigate, to change format between raster command, so raster format. So you can go, for example, from the typical ASCII file ArcGIS to TIFF, or from TIFF to EMG, from TIFF to NetCDF, and so on. So is translate, because it's really translating format. In the meantime that you make the translation of the format, you can perform a different kind of operation like cropping, setting up the projection. You can cropping based on lat long, you can crop based on row and number of the column. You can set up the data type. I will explain about the data type in details, and so on. So we will cover most of these options, and you will see the use of them. In particular, we will play a lot with the dimension of the file for cropping and set up your study area. GDAL program. Another one that is quite important is GDAL DEM to perform a different kind of topographical analysis using digital elevation model. So we will see how to create slope and GDAL and different kind of terrain roughness index and other kind of DEM derived variables. There are some of them that are not well used. Let's say they are not really. So we will try to skip it. Like for example, this one GDAL sieve is for filtering image to be able to remove little areas, so 1 to a pixel after performing a classification of an image. Rather, there are some other very important, like for example, GDAL calc that allow you to do band combination and band operation among the different raster format and so on. So all these ones that will be covered in the analysis, in the explanation. So then we have also the one that are covering vector programs. So they are the one that are able to use shapefile and performing analysis on shapefile, vector file in different kind of format. As we saw for the raster program, GDAL info, we have also for the vector program OGR info, and the OGR info to give you all the possibility to see the information in a vector file, not only the vector aspect, but also the attribute that are associated to this vector. Also for this one, you can have really you can crop you can see and concentrate your info in some part of the shapefile, and you can select different fields and so on. And also for this, if you're scrolling down to the page, there are always different kind of examples. So for example, whenever you do OGR info of a vector file, that in this case is this one, you will get all this information about the parameters of the projection. You will get all the different value of the corner and so on. So all these one allow you to perform other kind of analysis. So now let's move to the example, and we will go step by step to see to see which kind of operation we can do in a practical sense. So if you go to the program, I set up my page in this way. So now I can move this one here. Okay, so you were able to enter in the, if you were able to enter in the virtual machine, you can access directly to the to the directory where we have the file. So over here we are going to work inside here in a different folder analyze different files and so on. I'm going to present this material under Bash language. These are GDAL Warp, GDAL TIFF, all the GDAL application are really powered powerful because you can call directly from the Bash language. And the Bash language is still the most powerful language when you work in Linux computer. So in other words, the same kind of operation that you do it when you call it, for example, system from R, you can access directly using Bash in the same way. So I'm going to present everything under Bash, but later on feel free also to use GDAL by calling system inside R, for example. When you call it system, it's not R that is performing the analysis, but it's Bash in your computer that is performing the analysis. It's quite easy to operate in the language integration, so using R, GDAL, Python all together, especially when you're working in Linux computer, because all the different programming open source, they are really connected to each other. It's a bit more difficult, or I would say not so easy, and quite often is when you try to do this kind of language integration in Mac, or even worse in Windows, because the different language, they are very integrated better in the Linux computer rather than not in this other two operating system. So I always suggest, and I will show you in the end, how to start encoding and use Linux computer for geographical analysis. So, so for who is not familiar, quite often I'm going to use Bash command, that are really the Bash command and are not the GDAL ones. Like, for example, now that I'm listing all the files present in this directory. So as you can see, so also in your case, if you are using the virtual machine, you can do perfectly the same kind of command. The data are already there and everything should be working without problem. So for a GDAL info, for example, over here, if I get a GDAL info of one file, I can see that my file immediately has 700 and 600 row and column. There are projection information, pixel size, and also the corner of my image. So this is one of the first operations that you have to do. Even before to open the image, you have to understand how big is this image. So the information you can get with the size of the file. So this is a file of 1 mega. So probably you expected that is not very small. That is not very small. And so and then you can get also the information. You can get also the information about the you can get also the information about the image. Okay, so you can get the information about the image like I mentioned before. When the operation are when the operation you understand that you can open the image, you can perform OpenEV. OpenEV is a very old-fashioned software, but it's very fast in the terms. It's not a really GIS tools, so you cannot do it quite a lot. But as you can see, you can immediately open the image. So if you think about, we are working remotely in a virtual machine, so I'm connecting to my router, and I'm able to open the image without problem. So these allow you to really open an image in your computer, even if this image is really different gigabyte. Okay, so these allow you to open image in a very fast way, and we will see that you can open even several images in the same moment. So, for example,
we have a lot of people getting permission errors.
Yeah, please go in the right directory. Are you in the right direction?
Can you make that window bigger? We can't read it.
Yeah. Yes, it's like everybody has to enter in the right directory. So in the beginning of my talk, I was performing this operation. paste. Okay, so whenever you are here, so then you can, whenever you are in this directory, then you can, without problem, you can perform GDAL info.
Giuseppe, can you zoom in on that window that you're on now?
Yes.
Much better.
Yeah, probably there is some problem in some directory. Let's see. Let's continue, and then I will try to digging a bit more in this problem. The problem is just one problem with this file. So whenever you get the GDAL info, one of the most important part to understanding, and is not so obvious, especially in the beginnings, is the data type. Float, in this case, float 32. So the data type is very important because it's the range of your data and where they can go from to. So the data type is very important because you can manipulate in such a way and your file can become bigger or smaller. It can be able to ingest more data. So let me try to explain this concept. We have GDALs can support a different kind of metadata like byte, byte int 16, unsigned 16, int 16, and unsigned 32, and so on. So the byte, I'm over here reporting the minimum maximum of the range of the data that you can store it in the byte format from 0 to 255. So for example, you can see that is occupied 39 megabyte, the image. So what does mean storing file from 0 to 255? So for example, if I'm storing land use, and this land use is has 10 classes, so I can have from 1 to 10, and my 0 or my 255 can be recorded for the no data concept. Okay, so if I use it, for example, if I need I need to store information about temperature in Celsius or also in Fahrenheit, I cannot use this one because Celsius and Fahrenheit, they have also negative value. So I need to, for example, for using, for saving in Celsius and Fahrenheit, I can use the int 16 because I can go from -32 to +32. The same concept, this one, is for the digital elevation model. For example, elevation, I go from a maximum to the Everest, 80,000 and so on, to the negative value of, for example, Death Valley or Death Valley or some other depression that are below 0. So also in case of elevation, I need the negative value. So these allow you to perform this kind of operation and to storing this kind of data. So there are some other int 32 and even more float 32 that you can store very large data, okay? In particular, the int 32, you can arrive to this large, to more than 2 billion, and as a negative and as also positive. If you see the floating point, you can also storing not only integer value, but also numbers with a comma afterwards. So like, for example, 2.5, 2.3, and so on. So as you can see, the size is really going from 39 mega to 300 mega. So it's very important to understand which kind of data you are going to storing and selecting the data type in that way in particular. So these allow you to really use the data in in a better way, storing the data in the better way. Another important aspect that you need to understanding is the data type. Is the no data value. So in this case, for example, the GDAL info give this no data a very long number. Okay, whenever I perform the minus I can get the information about the minimum maximum. Okay, so in this case, my info file, minimum maximum, has my image that I opened before goes from 0.5 to 7.2, 7.4. So this large number is not included in my computational statistic in minimum maximum. So there are ways that you can change the no data. So you can specify another no data, and this is in particular with GDAL edit. So for example, with the GDAL edit, you can do GDAL edit -99, and you can select the same image. So GDAL edit allowed to alterate the data type, but also the metadata of the file. So at this point that you have set your no data -9, if you ask again the GDAL info, now you can see that your no data value is becoming -99, and what is happening that immediately your minimum maximum now changing. Why? Because the minimum maximum, the statistic, is not including the no data, and due to that we set up another value of no data. My minimum number again now is that one, and this is the part that is present in the image as no data in the area that is covered by water. So you see over here the no data area.
Excuse me, we have a couple of questions in the chat about the image size.
Yes, follow this one. What does the image size mean in this case? Perfect. So in this case, we were saying that the image size was 700 by 600. So in this case, is really the size of the pixel row. So in this case, 700 times 600 of pixel. So these allow you to understand how big is a matrix. So how big is this matrix in this context? Whenever you move in OpenEV, you can see that the pixel on the bottom over here, you can see this value changing. So this is the value of each single pixel. So that pixel, that value of the pixel can be stored in that information. So in this case, for example, this value that is 1.99 need to be stored with the float 32. That is the one that we were checking over here. And is the information that is stored also over here, float 32. So this is very important because allow you to understand the different kind of data set that you are open. Now you are open and you are visualized. If you move on the white part, on the black part, you can see that is this really long number. That is the one that is reported over here. So now this long number is not set as a no data, therefore is not set as a no data over here. So if we want to bring it back to the original position, so we can close the image, we can perform GDAL edit, and we can assign now the old no data. And if we open again the image, we can see that in the same area of the water, in the same area of the water now is loading. So now you can see that it is no data. The OpenEV is not fancy open source GIS tools. I will not say that is a real GIS tool. It's just a for visualizing image. The advantage of using OpenEV compared to QGIS is because you can really open several images in only one shot. So as you can see now, I didn't install QGIS in the virtual machine because if everybody was going to open QGIS, that will create a lot of problem in the transfer communication. Rather, in this way, it's becoming very light. We will see how to open several images in one shot and also different tiles. So this is really, you cannot do it a lot of operation. You can just zoom in, zoom out, change the stretching of the image, and so on. So it's really for a fast assessment of the visualization. You cannot do it fancy image. You cannot do it fancy image like a map or changing color or performing different kind of adding north and south like you can do it in QGIS. You cannot do it clipping, you cannot do it change projection. So all these operation just for visualize the image. Again, and I use this one quite a lot in my personal computer, but also in the cluster to allow opening several images. And we will see how to open as soon as we go down in the exercise. So the command that using GDAL through the command line is much more powerful than using through the QGIS for a simple reason, because you don't have another software interface in the middle. So when you use the QGIS interface, some of the RAM is used to maintain the QGIS live. So some of the RAM is used in that context. So if you use it GDAL, he cannot use it, the part that is used with the QGIS. So that's why it's important to running directly in the command line to perform this kind of operation. Moreover, now we are checking each single command step by step. But then you can building up a scripting procedure, GDAL warp, GDAL translate, GDAL edit. We will see PK tools. So you can really build up your scripting procedure in according to your needs. Rather in QGIS, you can do something similar with the Python code, but you can not really nest it each other with other programming language like in R and so on. So I prefer always to use the command line of GDAL or PK tools to perform the operation, and then another software, OpenEV or QGIS, to do the visualization and to see what I did, if it's correct or not. So these allow you to gain the maximum powerful of your computer without having another software intermediate in this context. So this program, GDAL program, they can also, as I mentioned before, they can also install it in Windows and also in Mac. Nonetheless, they are quite difficult. They are not so straightforward, and sometimes, quite often, all the different patches and version are more stable under Linux than not under Windows and under Mac. In the end of my talk, I will give you some tips how to install in your computer a Linux version that allow you to perform and to use GDAL in a powerful way. So now, for example, we started to understanding what does mean in a powerful way. We have running, for example, the GDAL info -mm option that was given to you. The minimum of each single image, so the range of your pixel value. So with a simple for loop, you can perform perfectly the same. You can perform perfectly the same for all the images. So as you can see now, we are in a virtual machine with different user locking, and the computation is very fast. So we are checking each single pixel for all this image, and we can even do it for all the image in the archive. So as you can see, now I'm scanning all the archive and I'm getting GDAL minimum maximum. These are very important, this kind of operation, because when you go for a massive data process, you are not processing only one image you can open one by one. No, you are performing several images that sometimes can be thousands of images. Even if you download it, for example, the Merit DEM, the digital evolution model, at global level, there are more than 1,000 images. So how you can get minimum maximum of all these images? So you need to perform a loop operation and be able to get minimum maximum of this image. The command grep computed in this case is not a GDAL command, but is a simple bash command that is able to get only the information that I need. Whenever I was performing GDAL info of the image, I get all the information about pixel value and size, extent, and so on, projection. So in this case, I can use it just grep computed and getting only the line that was going from only the line that was interesting. In this case, that include the word computed. So here, for example, there are a little exercise that usually I give time to do it, but due to that we are in a web seminar, I will try to see what we can do it. So as I mentioned, there are different options in the GDAL command. One of them is, for example, to crop an image. So I need to crop. So this is the kind of approach that you have to do it in order to understand which is the command that I use it and which one. So as a first thing, I was just Google it, GDAL crop an image. And immediately you will see, after searching a few examples, that there are mainly two commands that you are able to use it for crop an image, and is GDAL translate, okay, with the option project. You can insert upper left X, upper low Y, low right X, and low right Y. So are the corner of my extent. And with GDAL translate, so you just report the information over here. Pay attention that some of the command, they use different kind of labeling to say pretty the same. So in my case, X min, in my case, is upper left X. So in this case, I have to insert over here 32. X max, in this case, is 34. So I will insert over here because it's the third part. Then you have upper left Y. So is ipsilon mean, upper left Y, so is 1, and then 3. And then immediately you can put input and the output. So in my case, this one is going to be my computed one, the cropped one. Okay, so as you see, I'm already making a mistake by myself in selecting the wrong position. So probably is the 3. Perfect. So rather GDAL warp, for example, rather than using the project is using the minimum maximum. So as you can see, there are two commands, GDAL warp and GDAL translate, to perform the same operation. In this case, it's perfectly the same to use one or the other. This is to allow you to, for example, GDAL warp, allow you to make a projection transfer, so a reprojection of the image, in the meantime cropping the image. So this one, in this case, we were just making cropping. So in this case, we could use GDAL and also GDAL translate. Another operation that is quite common to do it is, for example, create the so-called raster operation. So between bands, you can do it, or between TIFF, you can do it different kind of combination, like classing two band or making a product between two band, like the NDVI and so on. So in this case, the most powerful operation is the GDAL calc. That of course, like I mentioned before, you can setting up the data type. In particular, pay attention that in this GDAL command, there is the .py. .py is a Python code. So in this case, when you don't see any .py, so when GDAL translate means that it's a code written in C++. When you see the .py means that is a GDAL command assembled under Python. Also in this case, you can have the selection of the data type. So for example, over here, we are selecting a create coefficient. So we are doing standard deviation, the value of standard deviation divided the mean. So our value will be a floating point. So we need to select storing as a floating point in order to be able to store the information after the digit. So in this case, if I'm selecting over here, copy, paste. So as you can see, I immediately do it the operation in a super fast way, and I can go back in the analysis. I can immediately run my GDAL info. So I can see that with the minus, I can get from 0 to 1.4. So my operation, the coefficient variation goes always from 0 to any number. So now I can open my image when I create it, and open, and I can see the visualization. So as you can see, I performed first the checking of the value of GDAL info, and then I open the image. Okay, over here again, if you move the pixel, the mouse over here, you can see that my value are changing down here. So in this case, the coefficient of variation is quite stable and understandable. What does it mean? The part that was considered no data remain with this huge number that later on I can use it and modify according to my needs. I can also change the pixel resolution with the GDAL warp. So for example, GDAL warp, I can, in this case, my file, this so in my case, for example, I have this file, and in particular, I have 12 of this file. One for each month. So for each one of these, I want to change the pixel resolution. So each one of these files is a log surface temperature. So I can open with OpenAV and show you the kind of image. It's always the same area in Kenya. So this is land surface temperature. So you can move over here and you can see the temperature of the surface changing. Okay, so for example, over here, you can say 26, 28 Celsius is the value. And when you go to the water, it's a bit colder than the surface of the land surface. So now, for example, over here, I can see that my original file are 1 kilometer resolution. So this is the typical digit of 1 kilometer resolution. And I want to go I want to crop the image. Okay. And in this case, I want to be sure that I can change or not change my pixel resolution. So for example, if I'm running all through the image, okay, so now I'm running through the image. As you can see, all my image now is being cropped. Okay. All the image has been cropped. and is a small study area. Oops. Ah, there we go. Okay, so now my image is much smaller and has been computed the change of the pixel resolution. And I can repeat the same image, the same analysis by just changing, for example, increasing the pixel resolution. So now I really do a resampling operation. So you can see that now my image, they goes a bit slowly because of course there are more pixels to be translated. So in this case, I can also change my resampling method. So if you go in the GDAL warp, in the GDAL warp manual page, you can go cubic. Under the resampling, the default is nearest neighbor. Rather, I can do different kind of resampling like bilinear, cubic, and so on. So these allow you to really perform different operations by just changing one line in the code. Something really important, especially in the context, for example, for GDAL, on the context of species distribution, is GDAL location info. GDAL location info allow you to retrieve the information of one pixel in a particular location. So you can have different kind of location. You can have pixel row in this case of the image, and we will see later on based on geographic information. So the same kind of operation, for example, if I want to, in all the pixel, drive information at 2020 row and column, I can just copy paste this line, okay? And I can perform the same operation. I can perform the same operation for the 2020 pixel. I can even perform more than one. So for example, this is starting to become, you start to use the combination of Bash language and also GDAL. So I can perform the operation for the first point, for example, then I can perform the operation for another point of the same image. So now I put, for example, here 23, 22. So now you can see that I'm performing the operation for the first point for the 12 image, and then in the second column, again 12 value for the same point. In the same way, I can do it perfect the same, but rather than using row and pixel, I can do perfect the same by retrieving information at a specific location. So this is great in order to retrieve information in lat long. For example, when I do species distribution modeling, that I need to build up my table for inserting in my modeling technique. So, for example, when you do the typical situation, you do this operation in R by the command extract. This command in extracting in R can be very slowly. Rather, with the GDAL location info, you can really drill into thousands of raster files and be able to retrieve the information at wide area. And in this way, you can build up your table that later on you can insert it in R. In this concept, R will be extremely efficient because you are inserting just a table. You are not going to use it, the full raster, or inserting in R the full raster, but just one part or just a little table, and then you can perform your analysis without problem. The same kind of operation, but rather than inserting manually, like I did, for example, in the previous operation that I inserted manually 2 points, you can have a little text that in this case, I just create a text file with 2 points at this coordinate. So now my text is just a little file with 2 columns, in 2 points, X and Y. But you can imagine that this file can be very huge. So with 1,000 of files, with 1,000 of points. So now I can loop through the column, through this point, and I can get information of each one of these points. How much is my temperature of this one? So in this case, it's going to be first and second point for the last image, the 12, first and second point for the 11, and so on. And so on. So with this simple loop, I can drill into all the image and be able to arrive to this. There are some cases that is really key and important to change a TIFF file in a text file. This is not, from a computational aspect, is quite wrong to do it, because a text file is always bigger than a TIFF, because it invites information, but sometimes it's the only way to perform some operation. So in this way, the GDAL translate, for example, you can go from TIFF file to text file using the option X and Y and Z. So your big matrix in TIFF is completely changed to a text file, okay, where you have 3 columns. First and second are the lat long, and these are the value of each single pixel. Okay, so in this way, I really changing my TIFF file in a text file, and the text file later on I can do a second operation. So I'm performing this as an example. For example, I can start to using combination of awk and bash and GDAL under bash in order to perform a second operation. So in this case, for example, I want to create a mask, a so-called mask, where all my value of the third column, so I'm here, they are considered between 2 and 4. Please insert 50. Or if not, if you are not matching this condition, you just insert in the value as it is. So now so as you can see, I'm really performing this operation in a very very old-fashioned language, but is extremely powerful in processing test file. So if you scrolling down, you can see that in any line that was matching this information between 2 and 4, now my pixel value become 50. So I manipulated just the third row. I didn't change any value over here in lat long. So what I can do I can transform back my file. I can transform back my file back to another image, do the same image. Now my file will be the one with the threshold 50, and now I can open again, and I can see that wherever I add that is one between 2 and 4, now my pixel value becomes 50. So you can actually, yes, so this gray area is completely now is completely 50. Okay, so this allows you to create an image that now is pay attention that I select byte. Okay, so now I have everything in byte. So what does it mean? That all my value, this one has been truncated to 4 in this case, okay, because they are in byte. In order to if you want a floating point, you have to make again the operation and be sure that you select float. Okay. So now your image Now your image, your value will be over here, yeah. So my white wine, the one that transform it to 50, rather this one are the one that stay constant. So in this way, you can manipulate your image through the text file. As I mentioned before, this is not really efficient from a computational point of view because creating a text file can become extremely huge. Actually, let's see how changing the size of this image in term of dimension of the file. So in this case, my previous image was the text image is 226K, rather the compressed one, the TIFF one, that was this one. Okay, these are very similar. I know these are very similar because the image is not extremely big. No, sorry, this one is the TXT. So as you can see, you went from 2.8 mega to a TIFF file of a few K. Okay, so really performing the operation in TXT file is not efficient, but sometimes you really need to see this value. So the only way to do it is, for example, to retrieve this information, or for example, then you want to select, if you have a text file, you want to select, for example, what is happening in only one lot information. So now, for example, you can grab all the value in the text file and see in one particular stripe how you're changing value performance. So this is, for example, a really common use to see if in one line of your image there are some mistake or some other kind of situation that can be achieved. So this is how you can perform.
Giuseppe, we have a question.
Yes.
Does GDAL only work with TIFFs or with other formats as well, like NET,
Perfect.
PDF?
Yeah, thanks for pointing. Like I mentioned before, it can be use it in really different format. Try to see page. Yeah, raster drivers here. So these are all the different formats that GDAL can support. The output as a default is always TIFF as a default, but then you can read all the different rasters that are present. So for example, let's Google it one, let's search NetCDF. NetCDF is a hierarchical data file, especially important for climate data. So GDAL info can read NetCDF. Or for example, another one, the HDF, the typical from MODIS and Landsat. So HDF 4 and 5, and 4 and 5, the different format. So GDAL can read NetCDF and also HDF. So about the SRTM, SRTM is stored in TIFF, or at least I download it always in TIFF. So without problem, he can use it TIFF file from SRTM. The HGTS, now I'm not really familiar with this one, but probably if it's a raster file, I would say yes, if it is a matrix raster file. So one of the previous question was related to the, for example, one person asking, what does mean? I'm just selecting a random number. I said, not random number, just performing $3 is my third column. So this one, and I will say, okay, if my third column is bigger than 2 and less than 4, put 50. So reprint again first and second column, and then use it and assign the value 50. If not, print it as it is. So in this case, I was able to retrieve my file and transforming only the third column by inserting $3. Okay. So in this case, I do not change the information on the first and second column, but only the third one. So in this case, you can really manipulate and combine the different operation of GDAL and GDAL warp, and changing to text, to back to image, or changing pixel resolution to perform several operations. So the tricky part is try to have in your mind the flow, and then transfer this flow that you have in your mind in operation that are in command that are already there. So we can see that with GDAL, you can perform pre-processing operation, and then later on, when you want to something a bit more deep understanding, you can use it PK tools, more not deep understanding, but a bit more elaborate with the PK tools. Perfect. For example, Christine, you just find out the raster. So as you can see, the SRTM, thanks Christine, it was just searching and find it. So this is the way how you have to really Google it and say GDAL supporting SRTM, HGT format. Yes. So in this case, a simple line. So probably quite often, not always, like now. There are also some example that you can use it, but in the same way I use it for TIFF, you can use it for the, and over here again in the digital raster, you can really see all the different formats. These are the typical, for example, ArcInfo from the raster file from ArcGIS that you can read and importing without problem. There are the, like I mentioned before, the MG for ERDAS image, typical ERDAS image format and so on. So in the meantime that you are using GDAL Translate, you can change the data type, you can change the node APLA, you can crop the image, and so on, all the different operations inside the GDAL Translate flag. So always read the manual. Always read the manual, and always have the manual. I keep, after 15 years, I keep reading the manual continuously. Also for something that I use so many times that I don't remember the syntax or I don't remember the flag, I use the manual. So feel free to really have your manual in your hands and try to use it. Another way to access the manual of all the GDAL command and any kind of is by the command man. So if you do command man GDAL warp, for example, you can get the command, and you can perfect the same as the one in the web. And quite often I use this one because it's faster for me. Rather than Google it, I just do man GDAL warp. I say, okay, I need source node data and destination node data to set up input and output of the node data in the two formats. Then you can press Q. So press Q to exit from the man. And the same for GDAL Translate and in all the different kind of GDAL. Okay, so so let's see some other kind of operation that we can do it. Let me put my screen here back to the. So another important aspect is the so-called VRT. VRT stands for virtual raster table text, virtual raster table of text, is nothing else than the combination of different TIFF, okay, different TIFF. In this case, I'm pointing 4 TIFF, actually 2 TIFF, in this VRT file. Okay, pay attention that the VRT is not a TIFF file, so it's not a raster, but it's just a hyperlink to the location of your TIFF. So in this case, if I run, for example, my build VRT, you can see this one is a very small file, is nothing else that a text file that you can open, So it's just a text file where I tell you that is combining two different files, two different TIFF files, okay? One the 0811 and the other one AT standard deviation 0811. So as you can see now, I'm create a new file that is called stack.vrt that is allow you to overlapping the two files with the option separate. So now the two files are completely overlapping, but I'm not creating a completely new file. So this is extremely important, especially for processing point of view, because you are not duplicating the file. So the data duplication does not exist in this case. You just create a new file that are combining the two bands, okay? So at this point, you can run to the GDAL info to this text file that will give you, in this case, what is going to give the information that you have between the two files, and you have the information of the two band, one, the first file, and second file over here. Okay, so in the same way, if you do GDAL info -mm, you can get the information minimum and maximum for the two files. Again, I'm not replicating the file. I'm just creating this virtual. That's why it's called virtual. And as you can see, it's very small inside because it does not include it, just a pointer, hyperlink pointer to where I located the file. Of course, if you move this file and you change the name or you change the location, the VRT is pointing something that is not working anymore, that is not anymore there. So it's quite difficult to to see. So let's see how we can use it, the VRT, in a clever way to perform operation. So quite often the image, especially when you go at global level, your image, they become so huge. Consider that whenever you create a TIFF file bigger than 1 giga, you start to get a lot of problems. In performing the operation, they are very extremely long. So you have to wait for several hours to get your TIFF translated, your TIFF change projection. For example, it will be several hours. You have difficulty even to open the image. So this complexity, this way of working with a really huge TIFF file is always not foreseen. So in this case, what you do? Moreover, having files that are extremely big is quite complex also from the computational point of view, because you have to wait a very long hours until that file is processed. Rather, what you can do it, you can split your image in tiles. So in this case, for example, I'm using the stack VRT that is including the two band, and I'm giving to them my source window in terms of pixel values. In other words, I've just divided my full image in four tiles. They really call it tiles, and I give upper left, upper right, low left, and low right. So by performing this operation with the GDAL translate, as you can see, I point to the VRT, paste. My GDAL is super fast. Now I have my 4 file that I can even open just to let you see. For example, now you can see that I'm using the bash flag, 2 question mark, to say any file that starts with stack with two character, please include it. And now OpenEV, without problem, is going to open the 4 image. So my image that we have been using for the beginning has been splitted in 4 different tiles. So you can see now you have this second panel that it didn't show before. So you can see that you can open, select, and unselect each one of these. Okay, so each one is a single tile. So now this tile is much smaller, and you can perform any kind of operation in that file. Whenever you perform the operation in that file, then you can assembling back, for example, the 4 tiles. So I'm listing over here the 4 tiles, create again a VRT, and then from this VRT, you can again to assign to recompute your image. In this case, you create a so-called mosaic. Be careful, in this case, my tiles, they were completely cut by this line. So whenever I do the mosaic, I'm going to, there is not overlapping pixel. So in this case, they're really overlapping in the same position, like they were, like in the same way I cut, I'm going to overlapping, I'm going to mosaic them again. So something that you have also to consider, that every time that you use GDAL, and this is extremely important, so please do it. So every time that you use GDAL WAR, GDAL Translate, and all the different command in PK tools that we will see tomorrow, always compress your image, because in this way you save it a lot of space in your hard disk. This image, if you don't compress, can be 10 times bigger or even more, especially floating point, not compressed. So always use this flag, -CO, compress, deflate, zeta level. There are different kind of compression. You can Google it. There is the JPEG 2000 and so on, but I always use this one that is one of the most compressed one. So by this operation, we can, you can really split the image in 4, do some operation that can be a filtering of the image, can be reprojection of the image and so on, and then reassemble it back. We will see on Thursday that these operations are extremely important, especially when you go in the multi-core processing, because each one of these can go in a single CPU and can be processed by a single CPU. So it can be that the join of all of them cannot be processed in a CPU because the image are too big, but each single one can be processed and is much more efficient to process all of them. So in this case, I can send each one to a CPU. So I will use 4 CPU for processing this image. And then when I get the result, I can assemble it back again by the VRT. So these are really complex operations. I mean, this is simple as an example, but then they can become extremely complex when you have thousands of images that you have assembled back, do some operation, send to the CPU, and so on. So this requires quite a good understanding and familiarity with this command in order to be able later on to implement this command for high performance computation in a cluster environment, or even in your laptop, you can do some kind of computation, because as we were doing right now, we are only using one CPU. So each one of these is managed by the same CPU. But also in your laptop, that most of them, they have 8 core, each one of these can go to a CPU to perform the analysis. So something extremely important also to know is that GDAL Translate, the GDAL WAR, they don't use a lot of RAM. So it's very rare that you will have RAM issues, or at least not quite often, like when you work in R. So the multi-core operation can be done because each one of the GDAL Translate, so in this case you will use 4 if you are going to use multi-core operation of this one, then can be performed without any problem also in your laptop in a multi-core operation with the 4 CPU. Okay, so good question about how do you add file to a VRT. It's very, I don't think you can really add. So this one, I'm not 100% sure, but as we did in the beginning, this operation is extremely fast. Even if you have 1000 image, you know, is extremely fast. So I will just recreate a full VRT rather than adding, you know. Probably if you do it I mean, not probably, but if you have, for example, two VRT over here, you can, 1 and 2, you can create a VRT of the VRT. Okay, so if you have something like this, in this case, you are creating, you stop adding to the stack one to create a third one VRT. But most of the time, I just replicate the full process, and I'm not really adding to the VRT because it's so fast to replicate, so it's okay to do it. Okay. So try to use it quite, and pay attention about this separate option. So the separate allow you to overlapping the different teeth. So in overlapping, like creating a band, without the separate, I combine the different band in this way. So you have the mosaic effect. So something to consider also in the VRT is the is no data, source no data and destination no data. So if you have a mosaic, okay, of different images, so for example, you download the data set from Modis. So the data set from Modis where you have no data, that is labeled as no data, you want to compute a mosaic, okay, whatever is labeled over here with no data will be taken the value from the underneath tile. Okay, so this is quite good to perform a mosaic operation. But be careful, it's going to take just the first full pixel that he found. Any pixel with one value, he will just get it in order. So we will see later on tomorrow with the PK tools how you can create composite by taking, for example, the average of this pixel, because the VRT will create will get just the fixed pixel. But it's also good because everything that is set as an data is becoming a sort of transparent. So he will get the pixel value of the underneath. So this is very common to create a TIFF file using VRT and be able to have set as a transparent data and go through the different pixels until he found the first pixel with the data. If there is a second one, will be just mask out. So you will just get the first one in order. So be careful when you do this kind of operation and try to understand. Sometimes these information are not really easy to get from the manual. Sometimes they are not there. So how you do it? You do it a bit of reverse engineering to understand what it's doing. So you take two files, you overlapping, you see how it's treating the no data and which pixel is selected first or after. So this is kind of operation that I always do it to understand also, is the software working in the same way we're thinking, or is working another way? And then adjust my thinking and my processing according to what I found. So always a bit of reverse engineering to understand what the software is doing is really what you want, or you have to change the pixel process. This is a matter of trying and trying and using all the different combination in order to combine the different operation. One question was, does the VRT different resolution? Yes, it combines the different resolution, but be careful because it's just a hyperlink. Okay, so it could be that allow different pixel resolution, but then if you have to building up a TIFF, the TIFF does not allow having band with a different resolution. So then even from the VRT, you have to have a TIFF, then you have to select how to do this pixel, which of the pixel resolution you have to select. Something that does not allow is different projection, of course, because they have to have the same pixel, the same projection, because they need to be located in the same location of the Cartesian that you are using. And actually, you will receiving a warning if you have tried to build up a VRT with different projection. You will get something data set not the same projection, so I cannot do it at VRT. So it's really you can try. So try to use it as much as possible the VRT. because it is extremely powerful, especially because you don't duplicate the data. So it just hyperlink to something really existing. The VRT can be also, so if you have 1,000 tiles, then the VRT can also be ingested, like we did it over here, in PK tools. So we can use it inside PK tools, the VRT. You can also open completely in QGIS. Of course, you cannot open 1,000 images, but if you create a VRT of 10 images, then you can open QGIS without adding one by one. So I open it quite often to, okay, let me create a VRT of 20 by 20 image. In this way, I can visualize and see what if they look like correctly or not. And then you close that one, you open another one, and so on. So try to use it as much as possible. I have several examples of use of VRT for clustering computing over here. We are going to see in details some details in the high performance computing on Thursday. So over here in cluster processing, you can see the use of VRT in the different combination for cluster computing. Yes, is VRT mostly using in tiling? Yes, can be used for assembling tile or for assembling bands, how we see. And then this VRT that you get it, you can feeding inside another program. So perfect the same like I was explaining over here, that we take the image, we split it in four, then we do station and you are reassembling back image. So this is the kind of tiling in and tiling out, I would say, of the use of VRT. Yes, as I mentioned, they have to have the same projection, because if not, you will get a complaint. You will get a syntax error, not a syntax, a warning, like be careful, your image are different projection. You cannot, because if you're overlapping, there are also the way to force the VRT to ignore the overlapping, ignore the projection. But in that case, you are crossing over, lat long with UTM, so the two images, they will never overlap. So you have to perform first a projection or GDAL warp to allow you to overlap without problem. Okay. Let me scrolling if I see other VRT question. Okay, so something really nice also to combine for in the context of the VRT, there is this command GDAL tile index to create the shape or the border of these of your tiles. So now, for example, I have just 4 different teeth that I created, split in 4, but you can imagine that you have 1,000 images. So how you are going to see where they are located in the geographical space. So with the GDAL tile index, you can create a shapefile that has the border of your image. So again, if you open with OpenEV, you will have your shapefile, the tiles and the dimension of your shapefiles, okay, in the 4, and each one of these will be the corner that we selected before for making our tiles. So as you can imagine, you can have tiles all over the globe, and you want to see which one you are want to perform, or when you finish the 1,000 tile, okay, let me see, are all of them being created? Yes, you can cut it, of course, but you can say, okay, which one are the one that are not being created? The one in Australia, the one in Africa. So then you can. So with this one, you don't need to open all the 1,000 images, but you open the border of these tiles. So this is why it's quite important to use this GDAL index to understand where they are. let me read this. Assuming we have two images with different. Okay, so this kind of question, assuming we have two images with a different resolution projection. Okay, first of all, the projection, you have make a in order to make a mosaic, you have to transfer to the same projection. So the same projection need to be arrived first. Okay, in terms of resolution, the pixel the size resolution has to be really matching the projection of that you are selecting. So, for example, if you want to go from UTM to lat long, 90 meter is more or less 90 meter in UTM is more or less 3 arc scene. 3 arc scene is more or less 90 meters. So you cannot really change in the projection and the resolution completely an off-flat resolution. You cannot go from 3 arc second to 5 kilometer, or even worse, from 3 arc second to 1 meter. So this is, you are to always try to select your resolution in according to the matching. You can upper scaling the resolution, so aggregate your data, and then perform a second aggregate your data. Whenever they are in the same projection under the same resolution, then you can overlapping without problem. Okay. Then you can overlapping without problem. Another so whenever you do the projection and the mosaicing them, then we can see tomorrow, for example, with the PK tools, that you can select the mean of all the pixels that are in overlapping, or for example, the maximum of all the pixels that are in overlapping. So this kind of operation. In this case, you can combine pixel resolution, but again, you cannot combine 10 kilometers with 2 meters. So you can combine 250 with 300 or 200 with 300. So try to always matching very close the resolution and do not working with downscaling without any kind of statistical analysis. You will get the output, but it's an output that is not really strong from a science point of view. Okay, another question can be okay. My shapefile in this case. Okay, so when I open, they were sort of square, but of course they can be rectangle, so they can really wide rectangle. So in this case, I'm just creating tiles by selecting the border. Okay. In this case, I cannot use it any kind of cropping system that is different by square or rectangle. Okay, so I'm just tiling, I'm just dividing my image. Whenever I need to perform some masking operation, we will see tomorrow with the PK tools how you can get rid of some kind of area, for example, water, some kind of area that are completely masked. And these allow you to use each single tiles with his own masking to allow some operation. Again, this splitting procedure is just rectangle. It's not a matter of masking analysis that we will see tomorrow. As you can see, there are some operations that are already anticipated that you cannot do it in GDAL. That's why it's useful to follow also tomorrow with the PK tools, and so on. So let me see some other question. Yes, again, all these operation that I was performing, you can use it also in QGIS in the model prompt that you have. Okay, no problem. But you always are through QGIS. Okay, so you can do the operation, you can do a bit of clicking procedure in QGIS, and you can also perform in some little script. But this one are really linked to the QGIS version that you use it first, and you have to have QGIS open, and the QGIS is getting some RAM from your computation. So I always, like I mentioned before, I always build up my scripting procedure in the Bash language, okay, running the full computation. So for example, like running all these one, you create a script, or you just download the script that is on top, and you can run all of these one. So when you have your scripting procedure ready to go, then you run, you get analysis, you get the final result, and then you open in QGIS. I would say that I use it QGIS only for visualization. Actually, I do first visualization in OpenEV to see if it looks like fun, nice, and I open in a very fast way. And then if I want to create a map, I want to do something more fancy, I want to zoom, change color, zoom in, zoom in, selecting C vector, vector file overlapping, do some clipping, do some fast clipping, then I open QGIS. But usually I do all my procedure in the script routine that we will see how to combine under Bash. We can see how to combine computation in GDAL, in PK tools, in graphs, and in the high performance computing, and also nesting inside Python and R. So you can see all these tricks and way how to computing in this section, language integration, where you have all the combination of this language in particular. So this, let me see some other. Yes, so the same. Using GDAL in R by system command is fine, no issues. In that case, your engine, even if you're inside R, your engine is going to be the GDAL command. It's not going to be R. So you will not losing in performance. So not problem. So actually, I always suggest to do all the kind of analysis with GDAL, all the GIS analysis with GDAL, PK tools, and graphs eventually, and enter in R only with your table. So this is the most efficient way, because in that case, your RAM is going to be used only with the table that you are performing the statistical analysis. So if in the moment you do a cropping procedure in Raster, for example, with the library Raster in R, then it's quite complex. No, not it's quite complex, but first it's very slowly, and then most of your RAM is already occupied by the raster file. So rather cropping, like you mentioned, with the system command, in this way, GDAL is making really the engine that is making the computation, and then second, later on you can do the operation by ingesting your raster in R to do the modeling and then the prediction, because quite often when you do the modeling, you just performing the modeling based on a table, an extraction of this raster. Rather, later on, you can do the prediction in the full raster, and then eventually you import the full raster inside to your R environment. So let me continue a bit more, that we have a few more examples. Another kind of operation that you can do it is the typical situation where you want to create buffer around some feature. So the GDAL proximity allow to create continuity distance surface. This one is quite new, is present in the last 3-4 years in GDAL. Before it was not, so I was very happy when I found out that they produce it. So the GDAL proximity, now you give some specific point that you want to create a distance map. That's why it's called in proximity. In this case, I'm selecting, oops. Yes, select the wrong one. Okay, so sometimes it's becoming completely black because you have to stretch your image. Like here, probably I make some mistake. Okay, for tomorrow you can find out the mistake that I performed. I can select this one. So probably there is some little error over here where I create this one. So, but anyway, you can create a distant surface, and then you can create also a buffer around a specific point. So we can check it before. So this one is the typical situation that you have to do a bit of reverse engineering, because you get the output, you don't get any syntax error. So then you have to see why I'm not getting the right information or what I want. As you can see also here, I'm putting all my compression. Okay, so you can see where are the error and see. Probably this, maybe it's because I'm using this one. We will check together for this. Maybe I make a mistake upstairs and in the other script. So so for example, let's see. So let's see another example of using of GDAL for digital elevation surface that I mentioned before. So with the command GDAL then, you can perform, for example, slope operation. So if you have a DEM, so I have the DEM for the same area. I have a demo for the same area, a digital elevation model, so nothing elevation of from the GM TED. And you can calculate the slope. So as you can see immediately, these are quite super fast command, so you can really see immediately the result without waiting. Okay, so these allow you to see the slope without problem, and then zoom in, zoom out. And the same you can do for different kind of for the aspect, for example, or the different terrain roughness. Let's open one of these. Let's compute one of these of the terrain roughness. Okay, we always see that I'm putting the compression to compress, and as soon you do the operation, you can immediately see the image, or like I mentioned before, you can get the minimum maximum of this image and see if they make sense or not. Okay. Another one, the roughness, for example, is also always quite nice to see. So you can get GDAL info minus mm. Okay, so you can get the minimum maximum. You already know that is flow to this 1,500. You have no theta minus 99, and then when you assess that your value are in line from what you think, then you can say, okay, let me see the image, and now I can perform it and see. Okay, so these one are the value that you are checking over here. Okay, so as a default, pay attention of this. As a default, so the GDAL is always is maintaining the data type quite often, most of the time. So in my case, my DEM, okay, my DEM was integer 16, okay. When I calculate my roughness, even if I don't insert any kind of data type, but I can see that my roughness is becoming float 32. Okay, so in this case, there is an internal function that allow to the roughness to become floating, because they know that this value, the roughness is always a floating point. So it's done in automatically. But we have to be careful, because as a default, if your input is byte, without mention, without changing any data type, your output is going to be byte. If your input is float, it's going to be float. So always pay attention. The default is when you put in, you get out. But if you are using the data type that I mentioned before over here in this table, if you are changing this one, so if you insert in byte, as an input you have byte, but if you specify your output, it can be floating 32, and so on and so on. So always pay attention about selecting the data type in according to what you are doing, because the default in GDAL and also in PK tools, we will see tomorrow, is always to use the same data type or your in. Apart some particular application like the GDAL DEM roughness that we saw, that is changing the data type in automatically, but usually most of the time, the default is always keep it the same value for the keeping the same value for yes for the data type. So in general terms, the same kind of thinking that we have done so far with the raster in the perfect way, you can do it with the OGR to OGR. Okay, so the OGR to OGR, the OGR info work for vector file, any kind of vector file. So in the same way that you were Google it before, checking the vector file, clicking found the link, but if you go here, drivers, vector files, you can see that is able to open all the different vector files. So as a typical shapefile or JSON, there are plenty of them. I use it most of the time. I found shapefile, but you can get in GPX, or you can get JSON and PDF also, SVG. So all this one can be read by OGR info. And now you are getting familiar with GDAL, with GDAL, with GDAL, okay, here. So you can get familiar with the GDAL, but the same way of thinking, you have the OGR info that allow you, for example, to get the information about a shapefile. So let's see an example. So for example, over here, I have my globe that is just a shapefile with a country border, nothing fancy. Okay, just to show you what we are checking. Okay, so in this case, for example, so country border in VGS84, so you can already recognize the spreading of the upper part, so you can see immediately that is OGR, that is. So if you do it, so it's the same way. Before to opening, you should do it OGR info. Okay, so if you do OGR info, tell you the shapefile. Then if you put the -L minus all, you get all the lists, all these numbers. They are the corner of each single segment in my shapefile. In order to avoid that you list all these corners, you can put the geometry that stay for geometry. So you can get, by this list, you can get all the, for example, all the attribute table, all the list of attribute table inside your screen. So this is also quite useful in order to understand how many to retrieve information from the attribute table. So for example, if you want to see how many country you have in the world, so if you select, you grab the word name. So now you can select all the different names that you have. And then, for example, if you want to count, you do word count minus L, another bash info. Each one of these is pipe, okay? And you can see all the information that you have 247 countries in the world listed in this shapefile. So in this way, you can really manipulate, you can really get the information, not manipulate, but get the information about the OGR with OGR info. So for example, you can go one step further and you can start to analyzing the data and doing some clipping procedure or selecting. So for example, over here you want to select and you want to get only create a shapefile for one specific country. So you can select, now that you know that the country, okay, let me select one in particular. And then you can say, okay, where my attribute name is equal to Uganda, then you can create a shapefile. Be careful about this. Pay attention. We always do it input, output. Here, I don't know why they do the opposite. Output, input, okay? And then after 10 years, I still making mistake every time that I invert it. But they will, if you invert it, they will just warning, with a warning, they say you cannot create the same file, something like this. So pay always attention that the input is the second one and the output is the first one. So in this case, you can create the Uganda shapefile, as you can see, extremely fast. You can again open. Okay, you can again open, and you can see that I created the shapefile for just for Uganda. You can okay, this question is quite, does OGR function that PostGIS doesn't? I would say no. PostGIS can do all the different function that OGR does it, but PostGIS, you need to have the database, ingesting all the file in the database. So if you have to do some really simple operation to a shapefile, I will not building up a completely PostGIS database to do just to select Uganda, for example. So I will perform it directly in OGR. So if you are familiar with PostGIS, no problem, keep working PostGIS. But if you are not familiar with PostGIS and you want to do some shapefile selection or some shapefile manipulation, vector manipulation, then it's better that you do it in OGR. As you can see, PostGIS, thanks for the question, and you can use it also as SQL selection query inside OGR to perform an operation. And even more, you can do the query inside PostGIS. So if your data set is inside PostGIS, you can, there is a flag, I use it a couple of times, that allow you to do a QGIS query in OGR to select it. So in this case, for example, I'm doing this kind of operation like, like select from my shapefile all the attributes from my table where my size have an area bigger, my area of my country bigger than 1,000, just select it. So in this case, I will select only, shapefile that have an area bigger than 1,000, okay? So if you now you OpenEV, as you can see, OpenEV, I'm also opening without problem shapefile, and you can open shapefile and TIFF together. So now I'm selecting only big country. So you can do different kind of this kind of operation. And indeed, if you do OGR to OGR, you just press enter, or you go into the manual page, you can see all these options. You have some of them that are basic and straightforward, but you can do spatial query, so you can cut, you can select, as we see, SQL attribute, but you can even do something more advanced, even clipping, for example, with another data source. clipping with a specific expression where my country are bigger than or something like this, very complex operation in the shapefile. I use it quite a lot when I deal with the shapefile. And something, for example, that I use it quite common is when you have to adding an attribute, you have the attribute table, you have to calculate a new value based on pre-existing value in another attribute table. So in this case, what you do, you create a completely, so for example, you use it, the world borders, and you say, okay, you create a completely clone of your data. This is just create a clone of your data. So now you have the new data that is called area 100, and you can say, okay, create adding an empty column for now to this data set. So I'm altering the table, this table, I'm adding a new data set that is called add column, a new attribute, not data set, a new attribute that is called area 100. And then I give the dimension of my data type inside to the attribute table. And now at this point, I can populate this attribute table, this column, by selecting, for example, my, I have an attribute table, if you remember, in the OGR info that I was mentioned. Yes, this one. I have one attribute table that was area. Okay, it was just area. So in this case, I'm going to, let me grab this way you can see better. Okay, so I have all my area, and then at this point I can say, okay, create a new, populate the new attribute table. Please populate with area plus 10. I just adding a number that can be, you can do complex or mathematical operation, it's up to you. So now if I perform this one, it's going to do the mathematical operation in that attribute table. Okay, I think I did. Let's see. So now if you do OGR info, okay, now you have area 100 here. It's not the area 100 now, that is going to be your value of area plus 10. So these allow you to really making complex operation with the shapefile. So consider that whenever you go in the direction of really massive operation, I usually don't do it. I just converting all my vector file in raster file in order to be able to combine more efficiently. I don't do very big operation in vector file. So this is allow you to do the tiling system that I was mentioned before. This multi-core operation is done more appropriate. So you just go directly, you get your shapefile, you do your query that you want, and then you transform to raster file to do some kind of operation and so on. Yes, going directly back to that question, yes, you can connect PostGIS from OGR. You can just need to point. You don't really need to connect. If you just tell where is your database, then it's very easy to do query. You can just do OGR and PostGIS, they will come example. It's very easy to do this kind of operation. So this is where I want to arrive. Tomorrow we continue from PK tools. At this point, maybe we can leave it a bit of time for question. We overpassing the time, but I'm happy to continue to stay on, unless the Zoom go really down at 11. Christine?
Yes, sorry. I'm trying to answer some emails.
Perfect.
So we can stay on. We can stay on.
Perfect. So feel free to now addressing question. For me, it was a bit difficult to follow the question and also to speak. So let's go now.
Right. We had a number of questions for those who were trying to follow along with our server. They couldn't, it looked like the permissions weren't correct to execute the data files.
Yeah, we will check. This is really for
Okay.
us the first time that we are using these new environment for running workshop. We do usually do it one-to-one, I mean, person workshop. So we are testing this an option. I will take a look and be ready if there have been some issues. Probably yes, because you mentioned for the later workshop or even tomorrow. Today I'm running the same one in Spanish. So if someone, I will be able to fix this problem now that I have the, actually, Christine, if you can copy paste this question, just in case I can go to the question and see where are the failing of the, on the server point of view, let's say on the login accent and so on. And then eventually you can follow again the Spanish version and actually we will be able to solve this problem in the meantime. And
Giuseppe,
for
the only
tomorrow with the
problem with
PK,
that, Giuseppe, the only problem with that is we have other people using the same accounts at 1 o'clock.
oh, right. Yeah, sorry, yeah. So you can follow in streaming, but you cannot really log in, you're right. So please logging out when you finish. You can stay until 12, and then you be kicked out down, but feel free to listen. And tomorrow we are going to use the same kind of environment. Please, people that were today, tomorrow you have another ID. So waiting the Christine email to set up the new ID and check the ID now. We'll try also to maybe communicate better if there is these ID issues problem.
Yeah, I'll send out the emails for tomorrow's accounts after our 1 o'clock.
Perfect, perfect. So feel free now to address some questions that I didn't reply, probably may not relate to the server, because this one we will deal it later, but more related to the. Okay, for installing OpenEV, nice question. Uh, it's a bit not so easy, but if you follow the information over here in my webpage, if you go in installation, and you click how to create the virtual machine and reach Ubuntu with GIS software. Then you do OpenEV, you arrive to a location where give you all the tips how to install it OpenEV. Okay, so then install, do installation, and then installation over here. Then you click over here, you arrive to a page that you can search how to install it OpenEV. You have to play a bit to install it OpenEV. So in this line of setting up, rather than building up your completely Linux virtual machine, what I always suggest is to Google it. Actually, thanks for the reminder. Is to Google it OSGeo Live. So if you go OSGeo Live, so maybe Christine, you can paste this web page, and you click Live OSGeo. So this one is a virtual machine that you can download it. There are all the procedure over here that you can do two kinds of installation. You can install it as a virtual machine, and you can install it as a full installation in your operating system. So it's a Ubuntu system, light Ubuntu with all GIS, all the GIS software already installed. But you don't have PK tools, so you don't have OpenEV. So these are the only two GIS that you can install. OpenEV you can install it very no OpenEV. PK tools you can install with just apt install PK tools, and you get it immediately if you are in the OSGeo Live. Okay. Rather OpenEV you can follow the link that I told you before. So For users that want to really start in the geocomputation, I really suggest this one because it's already pre-cooked environment. You don't have to deal with the full installation. And again, you can install it as a virtual machine, this one, so you can follow this procedure. It's the easy way to do it because you can have your operating system even in Mac or in Windows, you can have your operating system stay the same. In the meantime, you have a virtual machine where you can start to learn. Then after 6 months that you will have quite familiar in the virtual machine, then you can shift to the full installation in your hard disk. So this is the most common um, suggestion that I give to the user for starting this operation. Let me see some other question, Doris. In terms of really building up your scripting procedure, you have different editor, okay? In the command line, you have different editor. The most old one, VI and Emacs. These are the two most old ones. Then there are quite modern, more modern one like gedit, Eclipse, um, the one that are in Python, Spider. There are plenty of them. If I have to say the truth, I'm using Emacs. Some other colleagues using VI. So your laptop is good to use it more advanced. Another one is Lime, for example, as an editor that is very efficient in your laptop. But as soon you VPN to a cluster, then the old-fashioned way, Emacs and VI, is always the more fast to use it. Okay, so is quite often we still use it VI and Emacs, especially if you're working remotely in this way. In the end, they are just which one you prefer to use it. There is not a real suggestion to use it, but still, for example, many people start to use Lime. I start to use it, but whenever I have to log in remotely in the cluster, then Lime is quite slow. So I always use it Emacs with really opening into the terminal to allow the coding in a fast way. Then let me see another question. So which kind of aerial image to get the best compression? I would say that the TIFF with the option that I was mentioned before, the compressed deflate, the one that I was using quite often. So compressed deflate zeta level is the level of compression. Is quite, but I have to always say, and also say that I didn't use so much drone image. So I'm not familiar if there are some other images that are more compressed. There is also the compression JPEG 2000 that is very heavy in compression. So usually all these compression, they are not damage the data. So it's just a seamless compression without any damage of the data. So always compress if it's possible. So Emacs, yes. And so the word is Emacs. And so, for example, I can show you, for example, if you want to open in Emacs, if you want to open in Emacs this scripting procedure, you open it NV, stay for not window. Okay, so you open directly in the terminal. But be careful when you are here in the terminal, because then you cannot use mouse. Okay, you have just a few options. No, you don't have neither these few options. So you have to do everything with the keyboards. Okay, and there are shortcuts to open and close the file, save it. For example, XS is to save it, and XE close it. So you have to really get familiar a bit with the Emacs, and the same with the VI. There are just different shortcuts in order to be able. But if you have to log in, like we are logging now, if you want to open using another one like gedit, please don't do it, gedit, because if you now you started, it's going to pop up as an external window, and this one it will be extremely slowly, especially if you work remotely with a server. And if you are through VPN, even worse. So always use Emacs or VI when you are remotely. In your computer, you can use anyone, it's fine. The most, the one that you like. The other one, so if you just Google it, Lime, um, scripting edit, Lime editor, you will find immediately the there is a version, a free version that you can do almost everything, and then a professional one. Uh, so also that one is quite immediately. Some other people that were asking if we organize summer school. Yes, we organize a summer school at Yale University, but also outside. So feel free to navigate in spatialecology.net. You will see there is a place where you can go into the mailing list and register for the mailing list. So if you just Google it, spatialecology.net, you can find the mailing list where we is in the first page when you enter. So over here, and then some other question, compression, batch file. Okay, for this one, Tamir, for this one, we will address it later on tomorrow. Is in the same, we will use it PK. Okay, first of all, you can use GDAL allocation info, as we mentioned, if you have a text file with the X and Y coordinate. And if you have a vector, you can convert the vector to a text file with the OGR info, with OGR to OGR. And then when you have the text file, you can feed in inside GDAL allocation info. Or we can see tomorrow, there are other PK tools like PK extract that allow you to use directly shapefile to have point shapefile to have your attribute table populated by the value of the pixel. Okay, installing OpenEV we mentioned. One new message. Visual. Nice question. In a JPEG with several layers, Joao make a really nice question. This is quite tricky, you're right. There are some files like the netcdf that are I don't have it over here. Netcdf, but anyway, if you Google it, you can see there. You have to enter in the subfolder in order to able to read the netcdf of one specific file. Let me see if I found an example. So whenever I don't have a netcdf, so I cannot show you immediately. But yes, this one, perfect. So when you so you have to point to the netcdf. So this is the file netcdf that you have to point with the GDAL info or GDAL translate, okay? And then inside here is the name of the sub data set that you want to check it, okay? So this allow you to enter, if you have always netcdf in the beginning, name of the file, and then name of the band that you want to do the operation. Sometimes it can be the name of the band or can be only the number of bands. So band 1, band 2, band 3. So in this way, you can enter in one specific file some specific layer of the netcdf and performing the operation. These netcdf and hdf are the only few files that allow band with a different resolution. And they are called hierarchical files because you can have these dataset, sub-dataset, and sub-dataset. So these allow you to perform this operation. So you have to specify over here the full path. Okay, and usually you get the, when you do a GDAL info of the file, you get directly the information in the GDAL info of this. So then you can copy this line and put it in your scripting procedure. Okay, some other question, let me scroll. Yeah, user, if you want, yeah, if you paste the command over here, is easy. So this one again, in the tomorrow in the PK mosaic, okay, PK mosaic is making those. So we will see tomorrow how to make a mosaic. So again, if you go into the material that was presented today, if you are really curious, you can scrolling down. One of the last command is PK composite that you can do mosaic. So unfortunately, all these tools, they don't have GDAL, PK tools, and many of these. We are not in, we are in the area of multi-core processing, but the software, not all of them, or very few of them, are in the multi-core area, in the sense that each one of these GDAL, they are always using one processor. Okay, so you have to always tile in with VRT in order to make the multi-core processing. There is only GDAL-Y, but they allow you to identify that you want to use more core. But if not, the only way to do it is splitting your tile in 4 or in 8, how much you want, and then each one can go to each single CPU. So if you want to go in that direction, there is all this section, cluster processing, that is really helping you to understanding the tiling. You already know how to do it. We saw today with the VRT. Then you can see how to send each single tile to a single CPU. Okay. As I mentioned before, don't worry about the RAM issues, because especially each single laptop now you have more than 20 gig RAM of, so you will not fill it up the RAM. Of course, don't, like I mentioned before, don't do it one image for giga, please. Always the image always less than 1 giga. If it's less than 1 giga, then you can, if it's bigger than 1 giga, then you have to split, okay, in tiles in order to manage 500, 600, 700 mega, no problem. That way the computer is very fast. You get the result in a very fast, efficient way, and you can assess your result and do the operation for all the full tiles. Okay? So don't try to solve the issues of with the multi-core processing using tiles that are smaller than 1 giga. Okay? So this one, I think I replied. Yes, also for the time of the NetCDF, the time of the NetCDF is coming out as a text file. Every time that you get in the, you are in the GDAL info, that you get info. So every time that you were getting the info, each information, again, I don't have an HCDF, but over here you will get all the list of time, okay? So that information can be retrieved in a text file, and then you can use that text file to go in that direction. Anyway, so there is also another, good that you point, there is another super, so if you just Google it, CDO. CDO is a climate data operator. If you, Christine, maybe you can help me. CDO, climate data operator, is another super powerful command line utility for working for the NetCDS. So if you have to do a lot of time series for 1000 NetCDF files, perfect, like Hamad Babos mentioned, use CDO. CDO is really super powerful with NetCDF. I did it, especially if you have to maintain your time series. Don't transform to TIFF, but use it as a NetCDF. And CDO can be combined even with GDAL to allow this kind of operation. Okay, So this is quite appealing. So CDO climate data operator. Just Google this, and you can arrive to the web page. And this one, in this one, you can install it in Ubuntu directly with apt install CDO, and you get it immediately. In my web page, I think I have some example of CDO, but I'm not sure. Yeah. Also, GDAL include command that and LiDAR data. Not really. For LiDAR data, we will see PK tools use PK tools use. Wait, I need to remember. I think it's yeah. So it's this one. PK2 ASCII to image. Okay, PK2 ASCII to image is able to importing. If I remember correctly, is able to import raster operation. Sorry, LiDAR file. No, sorry, not this one. No, it's not this. There is another one. One of these. So this one is one of these filter ASCII. Last two image. Yes, sorry. Okay. Last two image. This one is the one that is able to create an image from LiDAR data. Okay, so these are really appealing because you can select the maximum value for LiDAR input, and you get the surface canopy cover. Rather, if you select the last bit of your LiDAR, you get the terrain canopy, the terrain digital elevation model. So between the two, you can have an estimation of your biomass. Then there are also in grass. In grass, there are different package for importing LiDAR dataset. Okay. So concerning this question about water, about can you do the mean of in a specific area? So this one, for example, you cannot do it with the GDAL, or at least you can do the cropping of all your image with GDAL. When all your image between 2000 and 2005 has been cropped, then you can do the vertical mean. Let's say you can do the vertical mean with the PK composite. So PK composite allow you to do the vertical mean or PK stat profile, both of them. All of them we will see tomorrow. And again, if you're just scrolling down in the same material, you can see this PK composite already for tomorrow. This one I mentioned yesterday, and actually,
Giuseppe, we can't see the questions in your chat window. It's blocked out.
Okay. So you cannot see the question over here?
No, we can't. It just looks like a block with a bunch of lines in it.
Okay, so I will repeat by voice every time. Okay, I will read and repeat. So yes, let me see some of the question. Yeah, these are the compression. For compression, the best image compression. I mentioned before the compression, the data level. I use it always. That one is a good compression level. Then let me see some other. So if you want to paste some other, I can reply. This one I replied. This is also reply. The masking operation I replied. Okay. So, okay, I think we covered plenty of the question, at least the one that were technical. Let's see. Christine, what do you think? Shall we summarize everything?
Yes, there are no other questions.
Okay. So yes, so we talk today about the powerful of GDAL, and tomorrow we will address it, the PK tools, to follow up in the same line and under the same procedure. So as you can see, they were very fast and they were able to perform a different kind of operation, pre-processing, let's call it. And then PK tools will allow you to go one step further for the image analysis for raster environment, analysis. Then we will address it again on Wednesday. We will address in the use of Raster, an introduction on the use of GRAS, and then last day is going to be a Thursday related to the high performance computing for geocomputation. Okay. So Christine, I think we can close this section. This way I have also time to addressing something more for one in Spanish.
I'm writing a note to everyone in the chat.
Okay, perfect. Yeah, the same for the hyperspectral satellite image is perfect the same. Only one, rather than having 6 bands, you will have 20 bands or even 60. So it's not a big issue. Yeah. Yes, filling the questionnaire, please. That is also useful for us to understanding what we can improve it for next workshop and so on. Okay.